This video is intended for SAN admins who are new to configuring and enabling Brocade's Fabric Vision Maps policies. This is a standard disclaimer. If you need to reach me, this is my personal email address. Begin the subject line with FOSS API so I don't accidentally delete it. I decided to shut down the Consoli Solutions business. I'm retired and decided I'm going to spend some more time with music. And this GitHub site also has some additional documentation as well as some of the scripts we're going to talk about herein. I have some scripts, these two in particular, that I use to evaluate the SAM prior to enabling maps. I'll discuss some of these scripts as we go along in this video. For most people, the first time Maps is enabled, the log is flooded with alerts. That's not helpful and may actually hide problems that you should be paying attention to. Similarly, if you have a system to auto-generate trouble tickets, the trouble ticket system can get flooded with redundant problems. So the first thing I recommend doing is that you evaluate your environment first. The most common issues are cabling and fabric congestion. The script generator report I mentioned at the beginning does a good job of highlighting all of these. It also summarizes other potential problems that are found in maps, such as optic issues, failed power supplies, and so forth. Once you have cleaned up these known issues, you'll want to create rules that make sense for your environment. You should also think about how often you want to be notified of problems. A large part of the flooded log problem is too many notifications of the same issue. There are 4 default policies. The base policy is included with basic FOSS support. That monitors basic chassis stuff such as power supplies. The remaining 3 are a collection of default rules. Some of the policies may or may not include all of the rules, and those rules and policies become more stringent as you get more aggressive. Typically, I only recommend the aggressive policy for mainframe environments. The moderate policy is what I recommend for most newer SANs, if you have newer cabling and 32 gig capable SAN equipment. The conservative policy, that's for what I usually recommend to start with your mixed environments. You want to take a look at your SAN design. Sometimes you can't help it. You have older 8 gig or OM2. Now, ideally, if you could take that out and put it in its own fabric, then you can have a different set of rules for the older stuff and keep your newer fabric pristine. Of course, that's not always possible, but it is ideal. Keep in mind that you could use logical fabrics to do that. You don't need separate physical hardware. If you're going to share ISLs, then I highly recommend you put your older stuff in a low quality service zone. In fact, if you're going to keep stuff all in the same SAN just because you have to, I would recommend putting your older stuff in a low quality service zone. That's not going to completely eliminate any potential problems, but it will help minimize problems. The most common problem that I run into with customers is that the storage is all oversubscribed. Now, obviously, the simple thing, technical thing to do is to add more storage. That, of course, requires signature on a purchase rec. You got to budget cabling, install, support, and then, of course, you have to have floor space for it and cooling. And the later, the cooling and floor space turns out to be the most common problem people have. So if you're going to have an oversubscribed SAN and there's nothing you can do about it, then it makes sense to remove any fabric congestion alerts, because all you're going to do is flood the log with alerts that you already know about. Fabric congestion indicators in the report are zero buffer to buffer credit counts on your F ports. Those are your device ports. The most common cause of that is due to oversubscribed storage, but it could also be the result of faulty devices or device ports. And it could also be caused by some of the design issues we mentioned previously, where you have speed mismatches. You also have zero buffer credits on your E ports. Those are your ISL ports. It's not uncommon to run out of buffer credits on E ports due to the bursting nature of SAN traffic. But if they're excessive, this indicates that the ISLs are oversubscribed. Another indicator are C3 discards. C3 discards, those are your discarded frames. frames are discarded if they can't be delivered within a certain time. And by default, that time is 220 milliseconds. I don't recommend you change that time. The first thing that I do before enabling maps is to find and fix all of the issues that I know will generate maps alerts. This is one of the primary design features of the report utility. For a full description of options, follow the YouTube link. I'm just going to cover the options pertinent to evaluating the SAN for potential maps violations. I'll cover the BP, sheet, and group options on subsequent slides. The default SFP thresholds remain constant, so it's unlikely you'll need to change these. You may need to add a new SFP sometime in the future, but in the interest of time, I'm going to skip that. If you need any help with that, just send me an email. Bit error counters are cumulative since the last clear. I recommend clearing them after each time you run the report so that you know what time frame errors occurred in. If you haven't cleared stats in a while, consider running this again after 24 hours. This is just an example of what the command line might look like. Skip that dash sheet option if you're not making any changes to the best practice workbook. To create your own groups file, just make a copy of the groups.xlsx example, clear out all the examples that I have in there. Most customers use a simple alias naming convention that you could use with a wildcard, just like I have here. But if you need to do some search on other filters, you could do that by zone, you could do it by switch port name, worldwide name, and the other operators are regex matches, regex searching, and exact matches. You could also add another row for the same storage group. Although this isn't necessary, sometimes it's convenient to filter the best practice summary sheet on select issues. For example, if there are a lot of bit errors, set everything that is not a bit error to false. To do that, make a copy of the rules standard worksheet. In the run example, I named it my_rules. You can name it whatever you want. Just keep in mind that if you put a space in the name or a hyphen, to get it by the command line interpreter, you'll have to enclose that quotes. So I scroll down to the port section. I set everything that is not specific to a bit error on a port. I set that to false. There's also some other sections you're going to have to go through and set those things to false as well. So a few more things to think about. The thresholds for the internal temperature sensors are set to warn when the temperature is approaching the maximum allowable chassis temperature. I recommend setting these to a level much closer to your environment. This is because temperatures typically increase as equipment is added, thereby diverting some of the cooler air. You want to know when this is happening before you get to a critical threshold. To do that, using the report, scroll down to the chassis section, click on the chassis you want to look at, scroll down to the sensors area, and you'll see all the temperatures. I typically recommend doing this a few times over a course of a few days, and take the highest temperature, add 5 degrees C to it, and make that your threshold. Another thing to look at is to see if all ports logged in at the expected speed. Sometimes when you're taking a lot of bit errors, the port can't auto-negotiate, so what the optics will do is they'll go down to a lower speed and log in at that lower speed. That will certainly cause fabric congestion errors. To look at those, you go back to that table of contents on the report, scroll down to the zone groups, and follow that link. Now in this example, you can see that server logged in at 8 gig while everything else logged in at 16 gig. You'll certainly get some warnings if you have the warning enabled for fabric congestion on that. Another thing to look at, you can see that this array, well, I'm looking at the same storage array, but the second interface logged in at 16 gig when everything else in that storage array is logging in at 32 gig. So you might not see any bit errors on these ports if they logged in at a slower speed, but you're certainly going to want to fix that before you get started. And finally, how to modify maps rules and policies. So the quiet time is the most frequently changed parameter, lowercase def. That's unique in all the default rules, so you could do global replaces on that if you want to. Similarly, the same is true for the policies. I'm not going to cover how to make changes to the groups. In this example, we're going to disable all the performance impact monitoring rules. Be careful not to delete the unquarantined or the clear from the policy. And we're going to set the quiet time to 86,400 seconds. That's a day. And we're going to do that for all the 32 gig SFPs. So to modify the rules, the first thing you want to do is copy that maps report. Find the logical switch you want to work with. You could delete all the other logical switches out of that report. And typically what I do is I make a copy of that worksheet. The reason I do that is makes it easier to make changes. This FID, blah, 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 in the header, that is used by the script to determine which FID we're working with, so you cannot change the header. This is the copied worksheet. I deleted all of the rules that had something to do other than the 32 gig SFPs. I changed default all to ABC. I cleared out all of these predefined check marks, and I just changed all of these 3600s, that's 60 seconds or an hour, changed those to 86,400. So now you want to take those custom rules that you just created, copy all those rows, and insert them at the end of that worksheet where we define the rules. Don't make any other changes to any other columns. The one that might get your attention is the one where it shows the policies. That's a read-only column. We'll talk about how to add the policies later. I'm not going through a long-winded explanation as to why some rules may not get created here. My advice is to replace the default rules with only the rules that were created, and you can use the summary output of the script to determine which rules were created. So basically you're going to do this, run this utility twice. After you run that utility, I'm going to cover that in another slide or two. What you're going to do is you're going to go back to that worksheet. You're going to click on the policy this time. And then what you're going to do here is you are going to copy all of the members from, pick whichever policy you're going to start with, copy all those members to a Scratch file. And in this example, we're not going to include any of the performance impact stuff, so you would search for and delete those. They may or may not be present depending on which policy you decided to start with. And then what you're going to do is replace all of the default rules with the custom rules. And again, use that log output to determine which custom rules were actually created. So in this example, I'm just showing how you change from def to ABC underscore. Okay, so after the last row on the policy worksheet, what you're going to do is you're going to create your policy name in the policy cell, and then you're going to just copy and paste from that Scratch file you were working with. You're going to copy and paste all those members into the member cell. I knew which rules to stay away from, so I only ran this once, but my advice to you, again, is to run this twice. Once with just the rules defined, then use this summary output to determine which rules you could actually put in the policy. You'll get a failure if a rule in the policy doesn't actually exist. Once you feel comfortable that you have all the thresholds and parameters that you want to have, you'll want to push that to the rest of the FIDs in that chassis. And you're just going to rerun the maps config script. And with this -fm, this is a fabric map. What that says is take everything that you defined for FID1 and distribute that to all of the other remaining FIDs. And that IP address could also be the IP address of a different chassis, in which case you would probably map 1 to 1 through 127. Okay, maps config.py does not activate any policy. It just edits the rules and groups and policies. So typically you use SAN-nav, or you could use the CLI maps policy enable command to enable a policy. You could distribute maps using the restore.py. In fact, that's typically the utility I use. I like to do things scripted when I'm in a change control window because once you get the green light, you run the script. It's something you already tested. And when it's done, you're done. You don't have to worry about fat fingering commands in the CLI or clicking on the wrong policy in SAN nav.